Welcome back to the deep dive. One of the things I love about our listeners is they're always eager to get a handle on the really complex stuff, the stuff that's shaping our world, but they want to do it, efficiently, not spend weeks poring over academic papers.
Exactly right. Who has time for that?
Yeah. Today, we're all about giving you that shortcut, that express lane into understanding, well, in this case, it's large language models. We're talking LLMs and we're going deep, folks. This is like your personalized briefing on all the major global players in this AI arena as of, well, right now, early 2025. And all this amazing insight comes from the SubLimetechie thesis, which you were kind enough to share. I mean, talk about a treasure trove.
It really is. It gives us such a broad view of these powerful AI tools.
Yeah.
And what we want to do in this deep dive, I think, is go beyond just, listing features and specs. We want to
Mhm.
really tease out the differences that matter, the things that make each of these models unique in terms of how they actually work, how reliable they are, how they scale, where they get their knowledge from, and yeah, of course, what they're best at.
Absolutely get to those aha moments that our listeners love.
Exactly.
So the Sublimecki thesis breaks down this analysis into a few key categories, which is going to be our guide today. We'll start with the back-end architecture, kind of like the nuts and bolts, the design choices that give these models their uh, personalities, I guess you could say.
Yeah, their brains.
Yeah, exactly. And then we'll look at reliability and safety because, trustworthiness is huge, especially as these models become more powerful.
Essential.
We'll consider how they're made available, how they're used. That's scalability and deployment. Then we'll talk about data set sources, basically where these models get their smarts, their knowledge.
Their education.
Right. And of course, we'll wrap up with performance metrics. Like, what are these LLMs really good at? What are they not so good at? Where do they excel?
Absolutely. Let's dive in.
So, starting with architecture, one of the first things that jumps out from the thesis is that even though we call them all large language models, the engineering under the hood can be vastly different.
It really can. I mean, the way these models are built, it directly impacts how they function, what they're good at, and even their limitations.
Right, like they each have their own strengths and weaknesses based on how they're designed.
Precisely.
So, let's start with GPT-4. What's going on under the hood there?
GPT-4 from OpenAI, well, they're pretty tight-lipped about the specifics, but we know it's built on this proprietary transformer architecture that they've been refining. It's all about speed and efficiency. They're using this blend of what they call dense and sparse computation, which is, well, it's complex, but basically allows the model to process information in a super efficient way.
So it's kind of like having a really adaptable engine, right? Like
Yeah.
it can be powerful in general, but then also very focused when it needs to be.
Yeah, a great analogy. That speed is a major advantage, especially for things like real-time applications, like, those coding assistants that can help you write code on the fly, or when you need to generate content really quickly.
Makes sense. So speed and efficiency are the hallmarks of GPT-4's architecture. Now, Claude 3.5, this is from Anthropic, if I'm not mistaken.
Okay.
Their approach seems to be a bit different, right?
Yeah, they're coming at it from a slightly different angle. While they also use a transformer model, their primary focus is on safety and making sure that the model's outputs are explainable, understandable. They've put in a lot of work on safety protocols, and they rely heavily on reinforcement learning from human feedback, RLHF, to fine-tune the model's behavior.
Okay.
It makes their responses more aligned with what we humans would consider appropriate and safe.
That's interesting. So while it might not be as freewheeling as GPT-4 in certain scenarios, it's perhaps more cautious, more aligned with ethical considerations.
You could say that. It's a trade-off. The heavy focus on safety might make it a bit more conservative in creating tasks, but that's a priority for them and for good reason.
Right. So different priorities leading to different design choices. Now, what about the open source models? We're seeing a lot of activity in that space. What are some of the architectural approaches we're seeing there?
Yeah, the open source world is exploding, and there's a lot of diversity in how these models are built. One interesting example is Llama 3.2 from Meta.
Meta, formerly Facebook, right?
That's right. Their focus with Llama is on making it work well on devices, like your phone, rather than just in giant data centers. So they've designed it for on-device processing and also for what's called multimodal learning, which means it can handle different types of data, not just text.
Wow. So, like, you could have really powerful AI right in your pocket.
Exactly.
Yeah.
Of course, there's a trade-off. It might not be as powerful as some of the massive cloud-based models, but the benefit is lower latency, faster responses, because you're not sending data back and forth to the cloud.
And potentially more privacy, right? since the data's staying on your device.
That's a big one. And then there's the flexibility that comes with open source. You can customize it, deploy it how you want. Of course, you also need the know-how to manage the infrastructure, but it gives you a lot of control.
Makes sense. So it's like, with great power comes great responsibility, the Spider-Man rule.
You got it.
So that's Llama. What about Falcon 180B?
Falcon 180B, this one's from the Technology Innovation Institute. They've taken a different approach. They're using a dense autoregressive model, and it's designed to scale really well in cloud environments or for businesses that need to process huge amounts of data quickly. Think like analyzing tons of documents or real-time data processing for, say, business intelligence.
So Falcon is built for speed and volume, handling those big, complex tasks. What about DeepSeek? I know they're doing some interesting things with a hybrid architecture.
DeepSeek is really interesting. It's a Chinese model, and they're trying to find this balance between power and efficiency. They're using a hybrid approach that combines both dense and sparse computation. The idea is to get good performance without needing a supercomputer to run it.
That makes sense. So a more accessible kind of power. Now, Google DeepMind's Gemini 1.5. This is the one that's been making headlines for its multimodal capabilities, right? Images, video, the whole 9 yards. How are they pulling that off?
Yeah, Gemini is quite a feat of engineering. It can handle text, images, and video, all seamlessly integrated. To do this, they're using something called a mixture of experts, or MOE, architecture. It's like having specialized teams within the AI. Each team is an expert in processing a specific type of data, so whether it's text, image, or video, there's a dedicated part of the model that knows just how to handle it.
I love that analogy. It's like a brain with specialized department.
Exactly. And that's what allows it to be so versatile across different types of data.
Impressive. Now, Mistral also has a unique approach, particularly with their open weight models. Can you tell us more about that?
Yeah, Mistral's been making waves. They've released some really efficient models, like their 7B and 8x22B, and these also use this mixture of experts design, blending dense and sparse methods for efficiency. But the open weight part is really significant. It means that they're making the inner workings of their models more accessible, allowing researchers and developers to really tinker with them and customize them.
So it's like they're embracing this open source philosophy, wanting to make these powerful tools more available and foster collaboration.
Absolutely.
Now, Command R Plus from Cohere, I know this one is specifically designed for what's called retrieval augmented generation.
You got it, a RAG.
Right, RAG. How does its architecture support that?
Command R Plus is fascinating because it's not just about what it knows internally. It's about how it can access and use external information. Its architecture is all about efficiently finding and integrating data from outside sources. So imagine you're asking it a question, but it needs more context, more information to give you a really accurate answer. It can go out and find that information, pull it in, and use it to give you a more informed response.
So it's like it's got this built-in research assistant always fact-checking and deepening its understanding.
Exactly, and this is incredibly valuable for businesses because they have all this proprietary data, their internal knowledge, that the model wouldn't normally have access to. With RRED, they can tap into that, make the AI much smarter and more relevant to their specific needs.
That's huge for businesses. So instead of just relying on its general knowledge, it can actually tap into a company's specific expertise.
Precisely. It becomes much more powerful and accurate.
So we've got Command R Plus with its RAG capabilities. What about Jurassic 2? I know AI21 Labs has been focusing on long-form content generation.
Jurassic 2 is all about creating really coherent and engaging long-form content. Their architecture is probably designed to handle long sequences of text, to keep track of what's been said, and maintain that context over extended pieces of writing. They're also good at understanding structured data, like tables and databases, which can be a big advantage.
Yeah, you need that ability to follow a thread, so to speak, when you're dealing with those longer pieces.
Absolutely. Coherence is key.
So for tasks that require depth and an understanding of structured information, Jurassic 2 could be a good fit.
Yeah, definitely.
What about XGen from Salesforce?
XGen, that one's all about the business world. Salesforce has designed it with enterprise applications in mind, and a big part of its architecture is its ability to be fine-tuned. This means companies can take the basic model and then adapt it to their specific data and their own use cases. It's about customization.
So it's not just a one-size-fits-all solution. It can be molded to a company's specific needs.
Exactly.
Very cool. Now, the SubLimetechie thesis also dives into the LLM landscape in China, which is fascinating in its own right. What are some of the key players there and their architectural highlights?
Yeah, China's got a really vibrant AI scene. One model that's making a big impact is Yi-34B from A01.ai. Their focus is on making it super efficient and also making it work really well with multiple languages. It's designed to handle a lot of different languages with high accuracy.
So, a multilingual powerhouse. What about ErnieBot 4?
ErnieBot 4 is from Baidu, which is, like the Google of China. And they've really designed Ernie to be deeply integrated into the whole Chinese internet ecosystem. It can tap into Baidu's vast knowledge graphs and all their search data, which makes it incredibly powerful for applications within China.
So, it's got this home field advantage, so to speak, in terms of understanding and navigating the Chinese information landscape. What about South Korea? Are there any notable LLMs coming out of that region?
South Korea has HyperKiloVA, which is developed by Naver. It's a really strong model with a specific emphasis on understanding and processing the Korean language. It's a key player for AI solutions within South Korea.
So that regional focus, that deep understanding of a specific language is really valuable.
It really is.
And I believe Japan also has a model with a unique linguistic focus.
They do. Sakura 13B from Preferred Networks. It's designed to be really good at understanding high-context Japanese text, which can be quite nuanced.
So it's built for those subtleties, the things that might be missed by a model not specifically trained on Japanese. We've also got some massive models on the scene, these real heavy hitters like Megatron Turing NLG.
Yeah, that's a huge one. Megatron Turing NLG is a collaboration between NVIDIA and Microsoft, and it's all about scale. It's designed to handle massive data sets and really complex AI tasks. It's like an industrial-strength LLM.
So for those really demanding, computationally intensive applications.
Absolutely.
And then there's Gopher from DeepMind, which I know has its own architectural string.
Gopher is designed for really deep textual reasoning. It excels at tasks that require it to pull together knowledge from different sources and synthesize it, understand the connections, the bigger picture.
So not just summarizing, but actually connecting the dots, understanding the relationships between different pieces of information.
Exactly. And doing it across long stretches of text.
Impressive. And what about Wudao 2.0 from BAAI, the Beijing Academy of Artificial Intelligence?
Wudao 2.0 is another massive model, and it's particularly interesting because it's multimodal, meaning it can handle text, images, and even code. It's incredibly versatile.
A true jack of all trades in the AI world.
You could say that.
And then we have T5 and OPT, which have slightly different philosophies when it comes to architecture.
T5, this one's from Google, and they have this interesting approach where they treat all natural language processing tasks as a kind of translation problem. They call it text-to-text transfer. So whether it's summarizing text, translating languages, or answering questions, it's all about transforming one sequence of text into another.
So a unified approach to a variety of language tasks.
Exactly.
Yeah.
And then there's OPT, which stands for Open Pre-trained Transformer. This one's from Meta. And their goal was to make a model that was really efficient when it came to inference. Actually using the model to get results. They wanted to reduce the computational cost, which is a big consideration when you're dealing with these huge models.
So a focus on making these powerful models more accessible, less computationally demanding. So as we've seen, there's this incredible diversity in the architecture of LLMs. Each design reflects different priorities, different strengths, and of course, potential limitations as well.
Absolutely.
Now let's shift gears and talk about another crucial aspect: reliability and safety. As these models become more powerful, more integrated into our lives, how do we ensure that they're dependable and that they're not going to, well, go off the rails, so to speak?
That's the million-dollar question, right? And it's something that the developers of these models are very aware of. The SubLimetechie thesis highlights some different approaches. Some models like GPT-4, Claude 3.5, and Gemini 1.5 have really gone all in on safety measures. They're using things like reinforcement learning from human feedback, which we talked about earlier, to try to make the model's outputs align with human values and preferences. And they're also implementing a lot of real-time monitoring to try to catch any potentially harmful outputs before they get out into the world.
So it's like building in safeguards, but also having that watchful eye, that monitoring system to make sure things are staying on track.
Exactly.
What about the open source models? How do they approach safety and reliability?
Open source models, by their very nature, are a bit different. They rely more on the community, on researchers and developers who are using them, to identify and address any potential issues. It's a more distributed approach to safety. So models like Llama 3.2, Falcon 180B, Mistral, XGen, T5, and OPT, their safety depends on the vigilance and the expertise of the community that's using them.
So it's more about collective responsibility, that shared effort to make sure these tools are used responsibly.
Exactly.
Now, we've talked about some of the regional models, the ones that are specifically designed for certain geographic areas. How do those models, like DeepSeek, ErnieBot 4, and others, how do they approach reliability?
For those models, it's often about proving their reliability within their specific context, within their region. They demonstrate their dependability through how well they perform on tasks that are relevant to that area, how well they align with local data and the specific needs of that region.
So it's about showing their worth in their intended environment, demonstrating that they're a reliable tool for the tasks they were designed for.
Right. It makes sense, right?
It does. Now, what about those models that are designed for specific applications, like Command R plus for ag or Jurassic 2 for long-form content? How do they ensure reliability?
Those models often prioritize reliability within their specific domains.
Yeah.
So, for example, Command R plus A, because it's all about pulling in external information, needs to be really good at finding accurate and relevant information to augment its responses. It can't just be pulling in random stuff from the internet. It needs to be trustworthy in terms of its information retrieval. And Jurassic 2, because it's focused on long-form content, needs to be reliable in terms of maintaining coherence, making sure that its output is well-structured and makes sense over extended pieces of writing.
So it's about domain-specific reliability, demonstrating that they're trustworthy within their particular area of expertise.
Precisely.
Okay, let's move on to another important aspect, scalability and deployment. It's one thing to build a powerful AI, but how do you actually make it available to people, to businesses, to developers? And how do you scale it up to handle, potentially millions of users or massive data sets?
This is where things get really interesting. The way these models are deployed, how they're made accessible, and how they can handle growing demands. It varies a lot depending on their design and what they're intended for. Some of the biggest models, the real heavy hitters like GPT-4, Gemini 1.5, and Megatron Turing NLG, these are typically cloud-based. You access them through APIs, which are basically like doorways that allow developers to connect their software to these powerful AIs. And this cloud-based approach allows for huge scalability. You can have, theoretically, millions of people using the same model without it breaking a sweat.
So it's like these massive AI engines sitting in the cloud, powering all sorts of applications and services.
Exactly.
Now, what about the models that are designed more for businesses?
Models like Claude 3.5, Command R plus Ed, and Gopher, these are often also deployed in the cloud, but they're specifically optimized for the needs of businesses. They might be designed to handle the specific demands of enterprise applications or integrate seamlessly with a company's internal data for those RBAC applications.
So they're not just powerful, but they're tailored to the way businesses operate, the way they need to use data.
Right.
Now, open source models, we talked about how they offer a lot of flexibility. How does that play out in terms of scalability and deployment?
Open source models like Llama 3.2, Falcon 180B, Mistral, and OPT, they give you a lot of control over how you deploy them and how you scale them. You can run them on your own hardware, whether it's a single computer or a whole cluster of servers. But the trade-off is that you need the expertise to manage that infrastructure.
So it's like more control, but also more responsibility.
Yeah, exactly.
The regional models, we kind of touched on this earlier, but their focus tends to be on scaling within their own geographic regions, right?
Exactly. DeepSeek, ErnieBot 4, Yi34B, WuDao 2.0, and HyperSeal OVA, they're generally focused on making sure they can handle the demands within their own markets, leveraging local infrastructure and resources.
So optimizing performance for where they're primarily being used. Makes sense. What about those models that are really designed for business integration, like Jurassic 2, XGen, and T5? How do they handle scalability?
Those models are built with scalability in mind from the ground up. We're meant to be integrated into existing workflows and to handle increasing demands as businesses grow and need to process more data, generate more content, and so on.
So they're designed to grow with the company's needs.
Precisely.
Okay, let's talk about where these models get all their knowledge from their dataset sources. It's mind-boggling to think about the sheer amount of information they process.
It really is. We're talking massive amounts of data.
Yeah.
And the type of data they're trained on has a huge impact on how they perform, what they're good at, even their biases.
Right. It's like their education, their upbringing in a way. So where do these models get their knowledge from? Let's start with the big proprietary models like GPT-4, Claude 3.5, and Gemini 1.5.
Those models tend to draw on a really wide range of sources. They'll use proprietary data that they've collected and curated themselves, things that give them a unique edge. They'll also use publicly available data, things like web pages, books, articles, code, you name it. And then they'll use data that's generated through reinforcement learning, where the model learns by interacting with its environment and getting feedback.
So it's like a blend of formal education, real-world experience, and then some self-directed learning thrown in.
You got it.
What about the open source models? What's their knowledge base like?
Open source models like Llama 3.2, Falcon 180B, Mistral, OPT, and T5, they tend to rely more heavily on those publicly available data sets. Things like Common Crawl, which is this massive collection of web pages, or Wikipedia, or academic research papers. This makes their training data more transparent, more accessible for analysis and scrutiny.
So a more open book approach to their education.
Exactly.
Now, the regional models, I'm guessing they're mostly trained on data specific to their region.
You're right. Models like DeepSeek, ErnieBot 4, Yi34B, and WuDao 2.0, they're going to be trained primarily on data from their own regions, which often includes a lot of local language content and data that's specifically relevant to their particular markets.
Makes sense. You want them to be experts in their own geographic and linguistic context.
Yeah.
What about those models that are designed for specific applications, like RA or handling structured data?
Models like Command R plus A, Jurassic 2, HyperCLOVA, and Gopher, they're often trained on what we call curated data sets, meaning that the data has been carefully selected for its relevance to the specific task. So if it's a RAGA model, it's going to be trained on data that's specifically designed to help it be good at finding and retrieving information. If it's a model that specializes in, say, medical information, it's going to be trained on a lot of medical texts and research papers.
So it's like giving them specialized training, focusing their education on the specific skills they need to excel.
Exactly.
What about the big, massive Megatron Turing NLG? Where does its knowledge come from?
Megatron Turing NLG, well, they're using a combination of web scraping, basically pulling in huge amounts of data from the internet, and proprietary data sets that they've collected.
Yeah.
It's all about building a model that has this vast general knowledge base, but also some specialized knowledge that makes it really powerful for business applications.
So a mix of broad knowledge and specialized expertise.
You got it.
Okay, finally, let's talk performance. We've talked about how these models are built, how they're deployed, where they get their knowledge from, but ultimately it comes down to how do they actually perform? What are their strengths, their weaknesses? What are they really good at?
It is a bit of a horse race, right? Everyone wants to know who's the fastest, who's the strongest. But as the SubLimetechie thesis points out, it's not quite that simple. The best model really depends on the task. If we look at GPT-4, it's generally considered a top performer in things like creative writing, complex reasoning tasks, and coding. It's got a broad range of capabilities.
So it's kind of like the well-rounded student who excels in a variety of subjects.
Yeah, good analogy.
What about Claude 3.5? Where does it shine?
Claude 3.5 is known for being really good at logical reasoning. It can follow a chain of thought, draw conclusions, and it's also very good at generating long-form text that's coherent and well-structured.
So when you need something that's well-reasoned and well-written, Claude could be a good option.
Definitely.
And Gemini 1.5, with its multimodal abilities, I'm guessing it excels at tasks that involve multiple types of data.
Absolutely. Gemini is the go-to for tasks that involve images, video, and text. It can understand the relationships between those different types of data, which opens up all sorts of possibilities.
It's like the ultimate multimedia whiz.
You could say that.
Now, what about the open source models? What are some of their performance advantages?
Open source models like Llama 3.2, Falcon 180B, Mistral, and T5, they're often praised for being really efficient. And they're also very good at being fine-tuned, meaning you can adapt them to specific tasks and get really good results.
So it's that flexibility and adaptability that makes them stand out.
Exactly.
Now, the regional models, DeepSeek, ErnieBot 4, those models, I'm guessing they're often best at tasks specific to their region.
You're absolutely right. They're going to be really good at tasks that involve the local language, the local culture, the data that's specific to their region. They're designed to be experts in their own domain.
So you wouldn't necessarily use them for a global application, but within their own context, they're incredibly valuable.
Precisely.
Now, what about the more specialized models, the ones that are designed for specific applications like Command R plus for RAG or Jurassic 2 for long-form content?
Those models are really all about being the best at their particular niche. So Command R Plus is going to excel at tasks that require pulling in information from external sources and integrating it into its responses.
Hmm.
Jurassic 2 is going to be fantastic at creating really engaging and well-structured long-form content. It's all about focusing their strengths.
So it's about finding the right tool for the job, recognizing that different models excel at different things.
Exactly.
And lastly, Megatron Turing NLG, the behemoth. What about its performance?
Megatron Turing NLG is built for handling those massive scale natural language processing tasks, the kind of things that big companies need to do when they're dealing with huge amounts of data. It's a real powerhouse in the enterprise world.
So it's not just about being big, it's about being able to handle those big, complex tasks that businesses face.
Precisely.
So as we wrap up, it's clear that the world of large language models is incredibly diverse. It's not just one type of AI, but this whole spectrum of different approaches, different strengths, and different applications.
It's such a dynamic field.
And I think the SubLimetechie thesis really highlights this. It gives us this incredible overview of the landscape, helps us understand the nuances, the differences that matter.
Absolutely. And I think it prompts a really interesting question for all of us. As these models continue to evolve, what developments are you most excited about? What do you think will be the most transformative? Is it the pursuit of even more efficient models, models that can run on less powerful hardware and be accessible to more people? Or is it those breakthroughs in multimodal AI, where we can interact with these models using not just text, but also images, sounds, even gestures? Or maybe it's the development of highly specialized models, models that are tailored to specific industries, specific professions, or even specific individuals. What does the future hold for LLMs? That's something for all of us to ponder as we continue this fascinating journey into the world of artificial intelligence.
Lots to think about. Until next time, keep diving.